Hi, it's time for another math easy solution, and today we'll discuss improper integrals and go over a quick introduction to them. Basically, in my earlier videos in defining a definite integral, we went over the function from integral from a to b of f of x dx. We dealt with the function f defined on a finite interval, and we assumed that f does not have an infinite discontinuity. And basically such a function, if you were to graph it, it would look something, let's say this, just draw a general function with no discontinuity. You have a function like this, call this f of x, and then the area under it, this is from a to b, and this area is the integral right here. So that is the area, and area again equals the integral from a to b f of x dx. But now in this section, or this video series that I'll cover, basically we'll extend this concept of a definite integral to the case where the interval is infinite, and also where f has an infinite discontinuity in the domain a to b. So we'll look at these two. These are basically two cases. In either case, integral is called an improper integral. And one of the most important applications of this idea I'll cover in later videos, probability distribution, and again this will be discussed in later videos, so stay tuned for those. Examples of both types of improper integrals are shown below, and let's go over just for clarification purposes. So example of type 1, which is the infinite interval, so interval is infinite. One example is if we had, let's go with 1 up to, let's say, infinity of the function 1 over x squared dx. So this function, we're taking this is basically an infinite integral right here, or the interval is infinite, and if you were to graph it out, it would look something like this. We look at the positive side only. So 1, so this is a 1 divided by x squared. When you plug in 0, it goes to infinity, so the function looks something like this, and as you get a bigger number, it gets smaller and smaller and smaller. It's always positive. So at here, if this is x equals to 1, and now the area we want, this is y equals 1 over x squared. Yeah, and this area here, I'll get it in red. Let's make it a better line. So this is the area that we want. So area, this is the integral, and again, it's an infinite one because it keeps going on and on all the way to infinity. And now an example of the second type, which is an infinite discontinuity. You could kind of think about, it's the same function here, but same type, but you flip it 90 degrees. So an example here is, let's go from integral from 2 to 5 of the function 1 over square root x minus 2 dx. So now this function here, when you plug in 2 here, it's you'll have an infinite number here. 1 divided by 2 minus 2 is 0, square root 0. So you're gonna have a infinite discontinuity, and if you graph that function, it looks something like this. Again, this number, as you get larger and larger, you're gonna be dividing by large numbers, so it's gonna get smaller and smaller. But at 2 right here, let's go y, this is x equals to 2. At this point here, this is an asymptote line, and it's going to be something like this. And it's going to, again, get smaller and smaller. And then at here, this is our 5. Let's just say it's that. And this is y equals 1 over square root x minus 2. And the area which we will be solving using the integral is basically over here. And this area, and again, this is going to infinity right here. So it keeps going on and on, etc. So that's one. That's the other type. So you could basically consider these types as one of them has infinite, a horizontal asymptote right here. Another one is a vertical one like that. And in the next videos, I will go over the definitions of these types, and also as you can see, you could have both types in one. And then also further, I'll look further into these same examples which I covered for both of these types of improper integrals. So anyways, that's all for today. I hope you learned from this quick introduction video to improper integrals. And like always, you can download these exact notes in the link below. And thanks for watching, and stay tuned for another Math easy solution.